that's what kind of function?
In series, they are an and with
An and, right? If I take, like say you had two light bulbs. You had I don't know, say you had two switches and a light bulb. Then you guys do this in like grade 7 or something like this. If I have a battery and two switches connected together, I want the light bulb to go on and they're in series, then they both have to be on, right? For the light to turn on. So that's like an and function, right? And if I have two switches in parallel, like this, I have a light bulb. I want it to go on. I got a battery. That's like an or function, right? Either one of them closes, the light turns on. So this is an and function. And these things that are in parallel, A and D, for instance, is like a or function. So this would be A or B and C are together, but with this A, so that's B and C, and that's ORed with D. Right? Am I done?
No, you are missing the inversion overall.
Right. And I have to invert this whole thing. Don't forget that. A lot of times people forget that. Because when this is true, it's not like turning the light on. It's like pulling this to low. I get a low at the output when all these things are true. So I can either write it like this, or I can write it like Z bar equals that. I can do it either way. Common term is to write it like this. Z equals this. But don't forget that bar. Everybody get that? You know how to do this. Okay, let's see here. Let's get rid of all this stuff. Now we're going to use our Heisenberg rule, I guess.
Sorry.
Oh,
Could you
question?
explain why you put the bar again?
Because I said if A is true, or B and C are true, or D is true, if any one of these three paths is on, the output goes to 0, right? So it's like zero equals A or B and C or D, right? Right. So when these things are true, I get a 0. So you can think of that as being like the output bar. So you can say like Z is 0, right? You can put it like that, or you can just bring the bar over to the other side. Either way is the same, but that's what happens. Okay. Next question is for, so Isaac, we can get that, fortunately. Ezra, are you here?